In this video, I'll be working through the questions you see on the screen, and this question's from the winter edition of Cambridge International Exams from 2023 from paper 1-2. If you want any other questions from this paper, there should be a link to a playlist in the description below. I do these on a whiteboard, hopefully to mimic how you're used to watching your teacher teach these questions. And if you find any of this useful in any way, please like, subscribe, and even share it with some friend that's doing the exams or someone doing it next year. Question 7 starts off with this very simple algebra question, and then they move on to a bit of trigonometry, and then finally they want us to combine the trigonometry with the algebra to a big trigonometric equation at the end. So starting off to the easy part, they just ask us to verify that this equals this. All they want you to do, and some students get confused when it's too easy, they just want you to multiply this together and see what you get, and hopefully we'll get that. So 2x by 4x squared is 8x cubed, 2x by 2x is 4x squared, 2x by minus 1 is minus 2x, minus 1 by 4x is minus 4x squared, minus 1 by 2x is minus 2x, and minus 1 by 1 is 1. If we clean all this up, all the x cubes together, we get 8x cubed. All the x squares together, they actually cancel and we get nothing. All the x's together, we get minus 4x. And all the numbers together, we get plus 1, which is equal to what they wanted us to verify. So that's part A done. For part B, they give us a different identity. Tan squared theta plus 1 divided by tan squared theta minus 1 is equal at all points to 1 divided by 1 minus 2 cosine squared theta. And yeah, this is just like part 1. We just make sure the left side equals the right side and we're done. But it's a little harder. 3 marks for this. Very common to get trigonometry questions like this. How do you do it? My suggestion is to pick one side that you think you can manipulate more. It's usually a more complicated side, or in this case, it's because tan is in the left side. Tan, we know an identity for tan, at least hopefully you should. Tan theta is equal to sine theta divided by cosine theta. That should be fairly ingrained in you. There's other identities here with secant squared, which is, I think secant is 1 over cosine, but honestly, I always forget because we never really used it. Like, I have a degree in maths and I never really used secant until teaching the Cambridge course. So I don't really use it. But still, this should work out fine. If everywhere we take a tan, we go ahead and put this in it, we should find something interesting. So let's try that. We have a tan here, we have sine squared over cosine squared. That will turn into plus 1 over sine squared over cosine squared. Minus 1 is, well, let's leave the left side. We'll just try and make this look like the left side. Okay, what can we do here? We can multiply every term by cosine squared. Because that'd be equal. We're multiplying the top and the bottom by cosine squared. Multiplying the top by cosine squared means multiplying both of these. So this will equal, let's put it here. The cosine squared will cancel. We'll be left with sine squared plus 1 times cosine squared is cosine squared. And the bottom row will become sine squared minus cosine squared. Now this top row, another very basic fundamental block of trigonometry is the fact that cosine squared theta plus sine squared theta is equal to 1, and that comes up all the time. And also from this we can rearrange things, like for example we could say sine squared theta is equal to 1 minus cosine squared theta. So we use both of these here, and the reason I know to use this one, by the way, is we want the answer to have only cosines. So the top row easily gets rid of into a 1. The bottom row, I want to get rid of this sine squared because I know the answer doesn't have 1. So that's how I knew to do this. So the bottom row becomes 1 minus cosine squared minus another cosine squared, and we'll continue this one last row here. Minus cosine squared minus another one just becomes 1 minus 2 cosine squared, which is where we were going for there. So you didn't have to have a plan through all of this. You could have just played around with here and you should have got to this. From this point you should have started just cleaning things up and you should have got here. Here, sine squared and cosine squared should have screamed at you. It should have screamed at you that it would become a 1. So the next real trick was to know how to reduce this down to here, and that happens all the time. You can, if you get a sine squared, you can just put in 1 minus cosine squared. If you get a cosine squared, you can just put in 1 minus sine squared. So this comes up all the time. Okay, anyway, we've proven part B. I'll clean this off and we'll do the real meat of this question, part C. Okay, in part C, they give us this equation here and ask us to solve it, but they've given us a big clue. They tell us to use part A and B. So that should be a big clue. Not yet, I don't see why that's obvious yet, but it should be obvious that instead of this for part B, we should use this. So instead of this guy, we should use this one here. So 1 minus 1 minus 2 cosine squared is equal to 4 cosine squared. So it's still not obvious why the top row becomes important. But if we play around with this equation, hopefully it will become more obvious. So if we multiply both sides by 1 minus 2 cosine squared, we get 1 is equal to 4 cosine theta, that's 1 times this, minus 8, so 2 times 4, cosine cubed theta. Still, this might not be too obvious, but it's starting to look a little like this one here. 8 something cubed, 8 something cubed, 4 something, and there is in fact a 1. Let's try and make this look like this here. Let's move everybody over the left side. We would get 8 something cubed minus 4 something cubed, just something, no cubed at all, plus 1. That's identical to, and this is all equal to 0. That's identical to here. So the clue that we should use part A should now be obvious, that instead of using this, we can use this guy over here. So that becomes 2x minus 1 sorry, not x, 2 cosine theta minus 1 is equal to 4 cosine squared plus 2 cosine theta minus a 1, and all that equals 0. So we can, I'm going to run out a bit of room here. I'll have to rub out some things. But we have an equals, we have 2 brackets. It's already slightly factorized. We can straight away just answer this. This just becomes cosine theta is equal to 1 over 2. So if we put this equal to 0, 1 comes over, divides by the 2, we get cosine theta is equal to 1 over 2. That's one of the answers we're going to look for in this question. We still need some more. I'm not sure if it's 1 or 2 answers. It's on a different page. We should try and factorize this. Now, unfortunately, it doesn't come out evenly. It looks like maybe you should play around with it. 2 numbers multiplied to get 4. 4 and 1, or 2 and 2. 2 numbers to get 1, that's just 1 and 1. There's no combination, there's no easy combination that'll get 2 here. So you're going to have to use the minus b formula, or you could complete the square, but we'll go ahead and use the minus b formula here. So remember, that's the answer, in this case, not x, cosine theta is equal to minus b, which in this case is a 2, minus 2, plus or minus the square root of b squared, again that's 2, minus 4 times a times c, that's 4 times 4 is 16, times minus 1 is minus 16, minus by minus is a plus, and all that's divided by 2 times a, which is 8. We need, well, let me just squeeze it all up in here. Clean this up. This is square root of 20. This is cosine theta is equal to, we get 2 answers, minus 2 plus square root of 20 over 8, and cosine theta is equal to minus 2 minus square root of 20 over 8. Now at this point you can just solve both of these on a calculator. the inverse of cosine of both of them. The top one becomes, let me just double check my notes, 72. Again, I just put in a calculator, the inverse of cosine minus 2 plus square root of 20 divided by 8, and it'll give me 72. Double check the question actually. Yeah, they want all answers between 0 and 180. So that should work. The second answer would be theta is equal to 144, it'll come out as. And this answer down here, sorry, we never solved that. Cosine, to get a half, it's 60 degrees. Yeah, so just 60 degrees there. That's your 3 answers. 1, 2 and 3 answers there. Alright, sorry for squeezing that last bit in. Apologies for that. But yeah, you might panic when you get a big messy question like this. So many students, as soon as there's not a neat quadratic, they panic a bit. It'll happen now and then. And they do it on purpose. They want to test that you are able to solve a quadratic that's not simple, that needs the minus b formula or completing the square. Okay, thank you for watching. If you have any questions, let me know and have a great day.